Thank you, Hi. I appreciate the warm introduction. So for those who don't know me, my name is Marco Tundo. I am a master engineer from the University of Ottawa. I've been developing AI systems since my university career, decade ago now. And today, what I wanted to do is introduce myself and talk about something fun that I built. So a little more about me. I'm a tech entrepreneur. I have a few companies that I've built. Some of them are still operation, and I'm grateful for the people that operate them today. I currently do consulting in AI, so I work with enterprise in everything from LLMs to vision models to language, multimodal, chain of thought, you name it, I've tinkered with it. So what I wanted to talk about was something fun. So I don't know, maybe show of hands, how many of you just play with AI, not trying to make any money with it? All right, I think that's more than 70%. So yeah, you're a lot like me. I love just kind of tinkering and dabbling and showing what I can build, beats sitting on the couch. So what I wanted to do for my wedding, which I had in August, was do something cool for my guests. And you could think of like the photo booth kind of idea, but I wanted to build something really cool. My entire family knows me as kind of the techie nerd of the family, so they expected something pretty magical. So my idea was to put together a real-time generative AI camera setup with stable diffusion in the background. The primary goals was to certainly impress, try not to scare, Auntie Ellen or Grandma Sue, because, stable diffusion and AI can be kind of scary sometimes. So how do I make it fun? And then, of course, how do I distribute, like, let's say 700 watts 200 feet from my house and not cause a fire or burn through some electrical cord extensions? And it actually rained that day, so it made it even more fun. But yeah, how do I distribute that in the field in the back of my house? So Comfy UI. How many of you have heard or used Comfy UI before? All right, not that many. All right, so Comfy UI is an amazing product. Effectively, it's an open source Python utility that contains a UI and an API where you could kind of pipe together, I'm going to generally say AI elements together. They're referred to as nodes. It was primarily built for stable diffusion and kind of the generative image space, but now you can do text to speech, speech to text. You could throw in some LLM stuff in there. So it's actually become quite powerful. And it has a robust API that can be used in production. And a lot of the great AI apps that have gone viral certainly use Comfy UI in the background. So I've been using Comfy UI for a while, so I figured Comfy UI would be the right approach. So here's a really rudimentary sketch of the idea. So I wanted to have Comfy UI kind of operate on a PC, and then I wanted to have a custom client, a front end, to make the integration of the experience seamless as possible. So instead of serving the Comfy UI, I just wanted to use it as the API and build kind of this full screen interactive experience. I wanted to hide all the spaghetti string behind the scenes and just show the cool images in real time. Of course, I needed a model server to host the models. And an idea that I had was kind of distributed. Let's run it on multiple GPUs. Let's try to get that frame rate as high as possible. So I built a distributed system where I do frame buffer management, and then I could control UI parameters through the client that affects the REST request to generate the images, and then have the images sent through WebSocket to the client as efficient as possible. Cool. So this was the first version. This is just me sitting at my computer in my man cave trying to figure out, okay, what's wrong with this video here? So the first thing I noticed was that you're getting kind of that jitter. You're losing out on that frame consistency. So the frame rate is decent, but you can see in the top left corner, it's kind of hopping around. And that's kind of the frame buffer management system that's required to kind of ensure that you're getting that real-time feeling, but you're also not causing any jitter, because it's certainly unnerving. So what did I do to continue development on this system? Well, for one, I tirelessly tested different samplers and schedulers. So what's a sampler and scheduler? Think of it like when you have noise and you convert the noise to an image, which is what ultimately what a diffusion model kind of does based on its training data, where it was trained in the reverse of taking images and converting that to noise. When you take the noise and convert it to an image, you need a sampler and a scheduler to kind of discern how that noise is converted to the image. And they all do it kind of in different ways based on the speed in which it kind of affects the noise to produce something visual. So all of these different schedulers and samplers, they all take different, they all do different outputs, different rates of speed. So it was about kind of testing each one and finding kind of that balance of quality, speed, and consistency with the scheduling and sampling. And then of course, the temporal frame consistency. This is a big one. So unlike the frame rate consistency, temporal consistency means that the frames kind of coalesce in a sequence that feels natural. If you were providing the diffusion model a single frame, it's going to issue that frame through an image-to-image process, but then the following frame has no knowledge of the previous frame. So when that happens, you start to see kind of these abstract constructs just kind of popping in, and especially as the frame rate increases, it becomes more jargled and messy. So you want to kind of focus on temporal frame consistency. Now, maybe many of you have seen on Twitter some of these people taking video-to-video models like Gen 3. They'll take a video, they'll throw it into Gen 3, and they'll get a very highly consistent, a temporal consistent output video. That's because the video-to-video model has the knowledge of all the frames, so it could kind of make the assumption of how things move in time. Whereas a system like this doesn't have that. It's real time. So you really have to think about how to maintain that temporal consistency. And I think there were some caveats, but there's certainly more work to be done in that space. Yep. All right. So this is my favorite rapper, Bobby Shmurda. So here, this example, I think there's a way to make it higher quality. If I tap that. So I would actually use YouTube videos, particularly rap videos, to test kind of the speed and temporal consistency, because rap videos are fast, there's a lot going on. So here you can see we have marble statue, and I could watch the video pretty consistently. We're talking about 21 frames a second. It did drop there, but it more or less feels quite consistent. Also, I don't know if you've seen the UI on the screen, but we have a denoise parameter here, which affects the model's ability to kind of shift the creative nature and then kind of ground it back to reality. So here you can see I'm increasing the denoise, and it's just turning into visuals of marble statues, and then as I decrease the denoise, you can see it's turning more into the original video. Furthermore, steps are also a consideration in this. There are certain limitations to how many steps you could perform to get kind of that coherence. But this is just an example of me kind of playing around with my gangster rap obsession. All right, so how did the wedding go? Well, it was interesting. So before the wedding night, what I did is I got a little wireless tablet here, and I started looking at my living room with a prompt of 70s kind of style, and I was testing to see what the wireless performance was like. So the tablet is streaming the images to the server. The server is returning those images to the tablet. I wanted to see what that looked like on like a 5 gigahertz connection. This is just my beautiful wife and I on the couch, just kind of testing it out. So I quickly realized from that it wasn't going to work. So I brought the GPU into the wedding area, which is what I've done here as well. That bottleneck of network just wasn't going to suffice. So putting the GPU as close to the renderer as possible was critical. And then here's a cool little image of it being used at the wedding. So these are some cousins kind of playing around with it. Yeah, gangster rap, of course. They're looking like gangsters. And people were just having a great time. They were literally like, holy crap, Marco, this is the coolest thing ever. I don't know what I'm looking at. 98% of the people at the wedding had no idea this technology even exists. Furthermore, the only thing that they've experienced is whatever's on their phone, and this is certainly not something that you could run on a mobile phone. Okay. So here's another example of kind of thinking a little further down the line. What would it look like to stream a game through this system? Considering we got pretty good frame rates, we're looking at 16 frames a second. I believe this is 720p. So what would this look like? Certainly the game couldn't run on the same GPU that's rendering the frames. But this is an example of what can be done with this type of technology. And I don't know if the video here does it justice, but it's pretty darn cool. Here's an example of kind of a close-up shot. This is some work that I've done to work on that temporal consistency. So you can see there's a lot less flickering, a lot less extreme movement. You could argue that it's playable. The problem is that you can't look at any text, so it really isn't playable. There's no way to see the text. You're just taking the frames from the game and then just rendering them through this as a post-process. So I'll get to what the solutions are in a moment on that one. I may be missing a slide, but sorry, I might just be missing a slide here. Okay. Yeah, sorry about that, guys. I'm definitely missing a slide, but I wanted to talk a little bit. I wanted to talk a little bit about where this technology is going. So, in gaming in particular, you have tools like Reshade, which take frames from the game and kind of process them. They have information about the game. Maybe they have a depth map or some other type of imagery of the game that they can then run in real time. DLSS is similar, FSR. So this type of technology, you're going to start to see these diffusion models be integrated more into these post-processing engines. Maybe NVIDIA will charge this as a service through like GeForce Now. Maybe you'll have the ability to prompt how you want the game to look, but they'll be more integrated into the game. All the text and UI elements will be superseded outside the frame, so you'll get kind of the graphic effect without the text garbling. You'll start to see that as well. You'll also start to see this being included in movies, in television. You might have seen things like this. But the real-time element makes it fun when you're using it in video calls and for situations like this, art galleries, that kind of thing. What I'm fascinated about is the use of this in virtual reality. So I have one last little demo to show you. And feel free to add me follow me on Twitter and check me out on my website. I'd love to have you guys follow me, and I'll be sure to post more about how this is progressing in the future. But here's an example of a demo I have. So this is the game No Man's Sky. And what I've done is I've taken the actual side-by-side frames in the game, and I superimpose them and attach them to my virtual helmet in virtual reality. So this is actually in 3D. So the image you get is in 3D. Of course, there is that latency of kind of bobbing the head and moving around. One interesting thing I'm learning about is kind of my VR legs, in the sense that when you render a side-by-side image, you tend to get kind of two versions of something different, so things kind of cross, and if the denoise is too high, it starts to get quite jarring because your left and right eye are getting different renders. But because it's in the same frame, these models are quite good at keeping things consistent, especially with keywords like side-by-side. Yeah, so I've done a further test using a tool called Flux. Flux is the latest gen diffusion model, which is built more so like what you would see in a more LLM-based approach, the fundamental architecture. But Flux, you're looking at about 1 frame a second. So there's still some work to be done. But yeah, that's my talk for today. Thanks for listening. Yeah, so let's take on some questions.
It's quite interesting. Actually, I use Comfy UI to do something too, and also actually I create some video processing with Comfy UI. But yeah, the consistency from image to a video is hard to achieve. What you achieve is quite impressive actually. I just wonder that you have the GitHub source code available, and also maybe the Confluent workflow available for us to check out.
Yeah, you know what I'll do? I will share the workflows in the AI Tinkers Discord.
Yes.
Just for you guys. Yeah, in regards to the temporal consistency, it is a very challenging thing. I've learned that the scheduler and sampler has a dramatic effect. So using certain types of discrete samplers can be helpful. The one I use is called DDIM. It's deterministic, so it does help between frames.
I forgot other model. What model you use for the generating the image?
Right. So I've used many models, but for the optimizations here, to nerd out on it, it's I generate the model through TensorRT. So I'm using a model called Photon that I pulled off of Civit. I run it through TensorRT, so it runs as fast as it can on the hardware, on the 4090. Furthermore, I run it through Hyper, which was developed by ByteDance for reducing the amount of steps required to generate an image. And then I also use TAESD, the tiny encoder, because the VAE encoding to take the image to put it into the latent space to be worked by the model, that takes time as well. So the tiny encoder, you kind of get like blurry faces a little bit, but it reduces the time of encoding and decoding to JPEG or PNG quite quickly. And then I do some PNG JPEG tricks as well to make it stream a little quicker.
Thank you for the presentation. I have a quick question. Is it possible that we just change the property of the image by stable diffusion? For example, we just wanted to change the tourist color and to keep that color through the video.
Yeah, and that's the amazing thing about Comfy UI. Comfy UI provides nodes to do particular things like that. So the setup that I built is very workflow agnostic. So you could just build any workflow, and as long as you have the input node and the output node, whatever's in between can be whatever you want. And I actually tested quite a few different workflows with variety of different nodes, one being live portrait, which was a cool one. So yeah, certainly you can do kind of masking and different things. Just keep in mind that it has to be fast, right? If it's not fast, it's not fun. Yep.
Yeah, I wasn't there. Just a quick question. I saw you had multiple servers running there at the same time. What was the bottleneck? Was it, live parallel versus sequential? Was it like an optimization of hardware resources? What did you find?
Yeah, so I was running a single Comfy UI server and just kind of piping that through. The React code I wrote to connect to the WebSocket, I realized it was extendable. I just built a Comfy class. So I'm like, you know what, let me just try spinning up another Comfy server on a different port on the same GPU and just generate another class and then just run both of them at the same time. And it just so happened that my frame rate nearly doubled. So it just goes to show, if you don't fill your VRAM, there's a lot more left in the card to generate the images. Now, I do deal with VRAM issues sometimes, especially when I run SDXL models, so you have to be mindful of the models that you choose. But I've learned that the bottleneck primarily is networking, so sending and receiving the images. But other than that, if I could string together 6 4090s, I could run 4K 60 frames a second. Yet to be tried.